Hello everyone. Now I'm going to present our project one work. So this project is a group effort. Warner, Alexis, and I worked on this project. The project has three parts, and I'll be discussing on part one and part two. So, so in part one, which is basically identifying a network dataset and having at least one categorical variable. So we have used the Deezer Europe Social Network dataset for this assignment. The dataset was originally collected from the public API in March 2020, but now it is available as a CSV file on Stanford University's dataset collection site Snap, and from where we basically obtained it. So the dataset has more than 28,000 nodes and more than 92,000 edges. Each node here represents a user from European countries, and edges represent mutual follower relationships. So the user, the gender is a categorical variable, and which has two levels, like 0 for male and 1 for female. So this dataset is suitable for us because it provides both the network structure and the categorical variables for nodes, which is a requirement for the assignment. So the dataset is a very large dataset, and the density is very low, like 1,00023, which means the network is a sparse network, and on average each user maintains about 6.56 connections, and the clustering coefficient is like 0.0959, which basically indicates a modest tendency towards small friendship circles where friends of friends are also connected. So in summary, I can say that the dataset with its binary gender levels offers a valuable opportunity for us to explore centrality measures across categories, assess homophilia, and compare how structural importance differs between groups. So in this analysis, we used Python. These are the libraries that we utilized. Uh, like Network X, Pandas, NumPy, Matplotlib, and Seaborn for visualizations, and then SciPy for statistical analysis. And so after having saved the file from the Stanford University site, we put the CSV file on our on my GitHub, and from there we imported the dataset in this work environment. And here we imported first the age, and then we defined a network graph, which is mentioned here as G. And then we have imported then we imported node attr, and then we created a data frame which has a node and gender, and then we saw the first 10 nodes, and here is the first 10 nodes. You see the first one is for male, the second one is again male, and the third one is male. So this is the first 10 nodes of our data set, and then we computed some basic statistics like number of nodes, number of ages, number of males, number of male nodes, number of female nodes, the density, and the average degree. Here you see the transitivity, which is basically the clustering coefficient. So I already mentioned about these uh, statistics, and then we extracted the largest connected component, and we found the largest connected component is 28,281, which is exactly same as the total number of nodes in the network. This means all nodes are well connected. So since the number of nodes and the largest connected component are equal, we used the entire dataset for our analysis. And now we are seeing part two, so which is basically on calculating of degree centrality and eigenvector centrality. And so for your information, degree centrality basically counts the number of direct connection a node has. Nodes with like a higher degree are more connected, and eigenvector centrality basically measures influence. A node is considered important if it is connected to other important nodes. So these measures basically help us identify which users are most connected and which users are most influential in a network. So here you see the coding part. We computed degree centrality, eigenvector centrality, and uh, then we got like top 10 degree centralities with nodes and their respective genders. And then we created a data frame having 4 columns: node, gender, degree centrality, and number of connections. And here, and then we printed the top 10 nodes, top 10 nodes by degree centrality with their number of connections. You see the female has the highest degree centrality, having number of connections of 172. And the similar way, we computed top 10 eigenvector centralities with nodes and their respective genders. And we organized them in a descending order by eigenvector centrality with the number of connections. And here we found that female again has highest eigenvector centrality, and number of connection here is 81. So based on these results, I would say that female is the most influential node in the network, as she has the highest eigenvector centrality, and that means that she is well connected to other highly connected and important nodes. And again, female has the highest number of direct connections, um, but her influence depends here mainly on direct links, which is like the degree centrality measures. So, and among male nodes, we found that the highest eigenvector centrality is 0.1824, and that has 67 connections. Uh, it shows that males also hold strong positions in the network. So overall, female nodes tend to occupy the most central positions in this network, both in terms of connectivity and influence. So, so that basically concludes part one and part two of our analysis. The next section, part three, will be presented by my teammate Warner Alexis, and who will basically continue with the remaining analysis and findings. So thank you so much for listening to me.
So, good afternoon. My name is Warner Alexis, so I'm gonna continue with part three. So, in the Deezer Europe network, we split the user by the node attribute gender, male and female. So, an average of two centrality. So, for degree centrality, the fraction of all possible user, a person is connected directly to a male mean of 0.00238 and the female mean of 0.00234, with the number of attribute is 28,281. So that translates about 674 connection for male versus 634 connection for female. The difference, a modest difference, is about 6.2%. That match our degree in box plot showing right below these three codes. And then for eigenvector, centrality, which would tie or how well connected one neighbors are. So the male mean is 0.00942 versus 0.00768 for female. 22% 6 higher indicate that male are somewhat more represented in the network most influential core. So you see the male again centrally 0.948 and for female which is 0.78. So when we plot the distribution by gender, so what do we see? So we see that the network is sparse an average of 6.6 and local connectivity is essentially balanced by gender with only modest male edge. So global influence, however, show a clearer male tilt. Male are somewhat more likely to tie into well-connected part of the graph. So the t-test from our summary back this up. So now, so we're gonna go to the box plot of the degree centrality that we graph. So So the buck flags compare degree centrality, which we see like this, the number of direct connection our user has normalized for male versus the female user. So the box plots and the median are almost identical. So typical user has the same local connectivity regardless of the user. So both groups show a high outliers warehouse, but overall there's no stronger gender gap in degree of centrality. And also, we also plot a bar graph that essentially represent what we're trying to do. So this bar chart shows the sample size of Deezer data set, which 15,743 males or 55% of the database, and then 12,538 female is about 44% of the data set. So as we see is that this data set is moderately imbalanced toward male. So keep that in mind that when reading the stats centrally in per node, so mean that the means are comparable with large unequal group, even small difference can yield tiny p-value. So we also plot a pie chart that's so almost fully in the Deezer network. 52.5 of edge linked to people in the same gender, and then 4.7.5 linked to different gender. So given that approximately 56% are male and 44% are female, so random mixing will already produce about 50.6% of the same gender tie. So we observe 52.5, which is only 1.9% higher. So the bias toward the same gender it's real but mild. And also, we kind of create to compare the eigenvector and degree of centrality. So the scatter plot of eigenvector centrality versus degree show a generally positive relationship. So where users with more direct connection also tend to be more globally influenced in the network. So most node cluster near the origin with low value for both measure, reflecting the sparse structure of the Deezer graph. So however, several outliers stand out with disproportionately 8 eigenvectors centrally, even though their degree of centrality is only moderate. So this indicates that their influence comes not from having the largest number of connections, but from being connected to highly connected and influential user. So the annotated node represents the most influential user by eigenvector, highlighting how structural position rather than raw connectivity can drive global importance in the network. So the last graph, which is a subgraph visualization. So we color the node by gender and size. So some visualization are created to better understand the network structure. So the histogram degree distribution is plotted on log scales. So visual connection vary, highlighting the presence of highly connected hub. So we also describe the box plot degree centrality by gender, compare male and female connectivity, while the bar chart of class distribution display the proportion of user in each gender category. And then the t-test shows small but not clear difference between male and female node. For degree centrality, male have a mean of 0.028 and female of 0.24, which we said in the beginning, like the difference is between 6.2 and the p-value is 0.0025. So this means the result is significant. For again vector centrality, male has about 0.00942 and female is about 0.00768. The difference is about 22% and the p-value is 0.012. This is also significant. So for number of connection, male has about 6.73 and female 6.34 on average. So this confirms significance and offer an overall male shows slightly higher centrality and more connection than female in this network. So the Deezer Europe Social Network dataset provide both structure and categorical attribute, making it suitable for centrality analysis. So our results show that males and female have nearly identical degree, indicating similar level of direct connectivity. However, eigenvector centrality reveals statistically significant difference. So with male more often connected to influential user, so giving them a slightly greater global importance. So homophily analysis minor role in shaping connectivity in this network. Thank you.